Hello, my name is Paul. We are the team Best Girls from Germany, Berlin and Europe. With this video, we take part in an annotated programming skills challenge.
Yeah, and my name is Julius. Today we're gonna explain how we programmed our robot and how we use different sensors to perform autonomous operations.
We used 8 motors, 3 vision sensors, a gyro sensor, 2 limit switches and an ultrasonic sensor on each side of the robot.
On an early prototype, we used two vision sensors. Those are located in the front of the robot, and with them, we draw every detected ball that the vision sensor sees on the brain screen. So how does it actually work? Each vision sensor sees the ball in a different position. Combining them, you can calculate where the ball actually is compared to the center of the robot. We use this detection capability to make the robot follow the ball. The program constantly looks out for the blue ball and the robot turns towards the ball. We also measure the size of the ball. With this value, we keep the robot at a specific distance to the ball. With our third vision sensor, which is located in the robot, we can detect the ball's color and then decide if it belongs to us or to our opponent, as you can see here. As soon as a ball hits the limit switch, the filter decides if the ball is blue or red and then sort it out or let it pass. We use the same logic as we use at the filter mechanism to put the ball in a specific shooting position. The ball is transported until the limit switch is pressed and then the transport mechanism stops. We use our rear and right distance sensor to center us on a specific position and then use our gyro sensor to turn to 135 degrees. With that, we can ensure that we are in the center of the tower and then deliver the ball. As you can see, we use an X-drive. With this X-drive, we can't use the circumference of the wheels to determine the distance we travel. So we need to use the motor speed and the time for driving a certain distance. For that, we wrote a function to measure distance over time. We use multiple runs, and at the end of each run, we print the average speed to the screen of the brain.
For evaluation, we store all values on a SD card in the brain, which we can then use for analytics.
With the values, we draw graphs with the distance over time for each motor speed. We notice that the robot needs 300 milliseconds before moving at all. We use the different runs to calculate linear function. With that, we could then calculate the time to travel a certain distance. And now we come to our 60 seconds autonomous program. Due to the corona pandemic, we only have a quarter of a field built up, but we think it's good enough to show how our robot works and how our program performs. To start, we use the rear and right distance sensor to drive toward the second red ball. We use then the gyro to turn 90 degrees and the vision sensors to center on the red ball. When we use the front and right distance sensor to get to the corner tower, use the gyro again, followed by the vision sensors to center on the blue ball in the tower. To align with the side tower, we use the left distance sensor and the vision sensors on the blue ball. Then use the gyro to turn 180 degrees and visually align with the red ball and try to intake it. After that, we use the right and rear distance sensor to find our position in front of the middle tower. As you can see, the program struggles with the rear distance.
I'd like to thank our coaches and parents for supporting us when we got stuck and needed inspiration. Many thanks for watching our video and we hope you found it interesting and helpful. We are Best Ghost and we hopefully see you in Texas.